Hello friends and welcome to my channel AI with Grounding. I am a data professional trying to make sense of AI not from the hype cycle but from a place of reasoning, structure and evidence. Most AI demos look impressive and confident until you ask a question that requires real reasoning. That's when the confidence starts to crack. Because appearing confident is easy but grounding is hard. Language models don't know, they predict. They hallucinate, they fabricate, they guess, and the worst part, they do it confidently. So the real question isn't, can we make AI answer? But it is, can we make AI reason with grounding? Right now, RAG is the popular answer. It presented as a fix for hallucination, the architecture that makes AI reliable. But most RAG implementations stop at basic retrieval itself. They improve search and assume that reasoning will follow. But retrieval is not reasoning, and similarity search is not grounding. So today, I'm starting a new series, RAG from retrieval to grounded reasoning. In this series, we are going to treat RAG as an evolving architecture, not a quick implementation. This is not a one video tutorial, it's a progressive journey. This series follows an 11-step progressive roadmap. No jumping, no shortcut, no magic solution. We will build, we will evaluate each step, improve it in the next, and repeat until we reach a grounded architecture. We'll start with the simplest possible retrieval augmented generation setup and gradually evolve it into a more complete, more grounded architecture, step by step. Each video represents one step in that evolution. So once we complete all 11 steps and build a truly grounded RAG system, at that point, we are going to take a sharp pivot. Yes, the journey doesn't end with grounded RAG. In fact, that's where the next level begins. We will unlock two more powerful steps that completely change how you think about building reliable AI systems. So stay with the series because the real surprise is waiting for you. You should know basic Python to fully follow the coding portions, but even if you don't, you can still follow the conceptual progression. Because this series is not about code snippets, it is about architectural thinking. You should also know the basic concept and terminology of RAG. I will cover RAG as a concept in this video, but if you want me to prepare a separate video on detailed concept of RAG like embeddings and vector database etc., let me know in the comment section. Alright, so let's finally understand what this big buzzword RAG, Retrieval Augmented Generation, actually means. At a high level, it means instead of letting a language model answer purely from its training data, we retrieve relevant external information and inject that context into the prompt before generating the answer. In simple terms, search first, answer second. That retrieval layer grounds the model in data we control. Retrieval means search and retrieve chunks that are similar to the query. Augment means retrieve facts are added to the prompt as additional context. Generation means LLM uses this context to respond, which is grounded. And trust me, once you see the flow, you will realize it is not magic. It is just a very clever engineering pipeline. So why don't we see the pipeline? We start from the left side where we have our local data sets. These could be PDFs, documents, web pages, transcripts, database records, basically any knowledge we want our AI to use. But large language models cannot directly understand and search huge documents efficiently. So we do something which is called chunking. Chunking means we break big documents into smaller, meaningful pieces. Think of it like cutting a book into smaller paragraphs that can be searched independently. Now here comes the very important component, the embedding model. This model converts text into numbers, or we can say chunks into vectors. It can be either document chunks, which are highlighted in darker arrows, or it can be query, which is highlighted in the lighter arrows. Vectors are numeric representatives of meaning. These vectors are then stored inside a vector database. So instead of searching using keywords, now we are searching using semantic similarity. When user asks a question, the query is also converted into a query vector using the same embedding model. The system then performs as similarity search inside the vector database. Often, cosine similarity is used for that, which is like Tinder of keywords. And the idea of similarity search is to find the top k most relevant chunks. These retrieved chunks are what we call grounded facts. Now comes the augmented part of RAG. These retrieved facts are added into the user original prompt as additional context. So the model is no longer answering from general training memory. It is answering from specific retrieved knowledge. Finally, we reach the generation stage where the LLM takes the user query plus the retrieved contextual chunks and generate a response that is grounded, relevant, and factual. This is why RAG dramatically reduces hallucinations and makes AI useful for enterprise knowledge, private data, and real-world applications. RAG is simply a smart pipeline that finds relevant knowledge first and then asks the LLM to write an answer using that knowledge. And this simple idea is quietly powering most serious AI systems today. This diagram shows the basic RAG flow, but in real production system, there are many more optimization layers on top. Why RAG is important? Because large language models are powerful, but they hallucinate. They sound confident even when wrong. RAG reduces that risk by anchoring responses in external knowledge and making output more verifiable. Enabling domain-specific reasoning improves the reliability in real-world systems. If we want AI system we can trust, grounding is not optional. But here is the issue. Most RAG implementations stop too early. They build vector database, an embedding pipeline, a basic similarity search, and then they stop. They declare success. But retrieval alone is not reasoning, and similarity search alone is not architecture. It improves relevance, it does not guarantee logic. In this series, we don't stop at basic retrieval. We continue this journey until we achieve a reasonable grounding. So here is how we will do it. We will use a constant data set throughout the entire series. We will define 4 types of questions representing increasing complexity. Those same questions will be used at every step. And after each step, we will evaluate the performance. We will build a scoring matrix to clearly see the progression. This way, improvement is not subjective, it is measurable. You will see where each architecture change helps and where it doesn't. For this series, we will use a movie dataset derived from IMDb style data. The dataset includes movie titles, genres, ratings, release years, actors, directors, relationships between movies and people. This dataset is rich enough to test simple retrieval, filtering, entity recognition, multi-hop reasoning, relationship traversal. Don't get overwhelmed with these jargons. Don't panic. Everything will start making sense as we progress in this series. And we'll keep this dataset constant across all these steps. To understand how good our retrieval system really is, we are going to challenge it. Not with random queries, but with carefully designed questions. Think of these questions as boss fight for search. So question 1 is, recommend movies like Interstellar, emotional, cerebral, sci-fi, and explain why. This evaluates relevance and semantic understanding. This is not just keyword matching. The system must understand the vibe, the mood, conceptual similarity. Can it go beyond space movie and actually find films that feels like Interstellar? This tests relevance and early semantic understanding. Basically, can search develop taste? Okay, the next challenge is list top rated sci-fi movies after 2010. This evaluates filter correctness and constraint handling. Okay, now here things are getting stricter. This is not about vibe. This is about rules. Genre filter, time filter, ranking correctness. The system must behave less like a poet and more like accountant. This test constraint handling. Third mission. What movies did Leonardo DiCaprio acted in around 2010 to 2015? This evaluates entity understanding and temporal filtering. Now we introduce entities, real people, real timelines. The system must understand that Leonardo DiCaprio is not a keyword. He is an entity. Can system understand this difference? And around 2010 to 2015 is not fuzzy storytelling. It is temporal filtering. Okay, the last challenge for every step. would be, do the Matrix and John Wick shares actors, and who? This evaluates relationship reasoning. Now the system must play detective. At first glance, this sounds like a simple question, but actually, this requires the system to connect the information across different pieces of data. It's need to look at one movie, look at another movie, and figure out the relationship. This is no longer about keywords. It is about discovering connections. And this is where search start becoming truly interesting. For each step, we'll score the system against these 4 questions. On this screen, I'm showing a cross-step scoring matrix. The row represent architectural steps. Column represent question categories. Each cell will contain evaluation notes and a score. This gives us a structured, visible evaluation. No guessing, no vibes, clear progression. Think of today's video as the movie trailer. Lots of dramatic words, fast cuts, mysterious concepts, but the actual story we'll watch together in this series. So if you're interested in building RAG system beyond tutorials, if you want to understand what works and what breaks, and if you want to move from retrieval towards grounded reasoning, this series is for you. If it intrigues you, subscribe and enable notifications so you don't miss the next video. See you in the first building video, and as always, explore AI but with grounding. Thanks for your time.